Hi everyone, it's Joe again, and I'm here to give you another basic arithmetic lesson. Today I want to talk about factor trees, and factor trees have a lot of, they're a combination of multiplication facts and division facts. And I just want to show you that a number is, as you know, is either composite, which means it's made up of other numbers, or it's prime, which means it's not made up of anything else but itself and the number 1. So let me put a number on the board, and I want to break it down into all its factors, okay? So let's look at the number 20. There we have the number 20. Now, can you tell me the factors of 20? In other words, what things could you multiply to get 20? Well, you might think 4 times 5. Or somebody else might think, oh, how about 2 times 10? And you'd both be right. What I want to do is get to the very bottom with prime numbers only. Okay, so take a look at this. We have 20. I'm going to break it into 2 parts. And, oh, somebody might have said 4 times 5. 4 times 5. That's right. See, 20. And on this row we still have 20, only it's in the version of 4 times 5. Now, can I break any of these numbers down even farther? I certainly can. I can break the 4 down. I can break it into 2 times 2. The 5, I can't really do much with it. It's a prime number, right? So that's as far as it doesn't break down anymore. So what do I have on this row? I have 3 numbers. I have 2 times 2 times 5. And that's all there is. 2 times 2 times 5 is the same thing as 20. Now I'm going to go and I'm just going to make a spot over here. And I'm going to do this again. Only this time I'm going to, let's see if I get room here without falling. So I'm going to go 20 again, same question. And this time I'm going to say 2 times 10. Okay, 20, 2 times 10. We talked about that already. Now I want to keep splitting up these numbers into their prime factors. Okay, 2, we'll just kind of extend that down to there. And we're not going to bother putting 1s in, okay? We're going to put, what do you think we can call 10? We can call it 2 times 5, can't we? 2 times 5. So I'll just go over here, make that a little bit bigger. And guess what we have? We have 2 times 2 times 5. No matter what way you start, you always end up with the same factorization. Okay? Why do we need to know this? Because in a very few days, we're going to be reducing fractions. We're going to be doing long division and all that sort of thing. So if you look over into your 20 column on that times table sheet, you will find a 2, you will find a 4, you will find a 5. All those numbers are factors of the number 20. Okay, and I'd like to do one more. How about the number 18? Okay, 18, I want to break into its prime factors using a factor tree. We have, okay, how do you want to do it? Do you want to do 3 times 6? Or do you want to do 9 times 2? Doesn't really matter. In fact, I'm gonna do it both ways just to show you that we're not stuck to one way. So I'm gonna put 18 here. We're gonna do it one way, and we're gonna go 18 over here, and we're gonna do it another way. Okay, so maybe you're thinking, okay, well, I'm gonna go 2 times 9. 2 times 9. Okay, you know that 2 times 9 is equal to 18, and that's what we want. Every row must equal 18. All right, so 2 doesn't break down anymore, so we're just going to kind of extend it to the next row. And let's see, is there anything we can do with 9? Oh, for sure. 9 is equal to 3 times 3. And these are all, every number on the last row is a prime number. Once you have the last row and everything on that row is a prime number, you're done. All right, so I would say this is a good answer right there. Now, what about going the other way here? What if I went 3 times 6? Okay, so our top row says 18. Our second row is equal to 18. It's 3 times 6. Now 3 is a prime number, so I'm just going to bring it down. And 6, oh, 6 that's an easy one. That's 2 times 3. Let's put our multiplication symbols in there. And you know what we're going to do? We're just going to make a deal, just so that we're all on the same page and we can all compare our answers and quickly know that we got the right answer. I'm going to go and rearrange my last column if necessary so that the smallest number comes first. So I'm going to do that. So there's no real calculating here, but I will say this, that this is the same thing as 2 times 3 times 3. Okay, so this person got an answer, that person got the same answer. All right, and I'm going to give you one more. I'm going to go with 75. And again, I'm going to do this twice. I'm making a point that your neighbor sitting next to you or over in the other side of the city or the country might be doing this. They might do it in a different order than you, but it does not matter. So I'm going to say 75. Oh boy. 75. We're starting to get into some big numbers here. Well, 75 is not too bad because we're all used to dealing with money. And you know that 75 cents is like 3 quarters, right? So I could take 3 quarters, which are all equal to 25 cents, and get 75 that way. So I know that 75 is equal to 3 times 25. I would hope that we can all count by 25s, at least up to 200. 25, 50, 75, 100, 125. All right, I would hope we could do that, and I have a feeling you can do that. So 3 times 25. Well, is there anything we can do? Yes, we can just bring down the 3 because there's nothing else we can do with it. But the 5 breaks up, doesn't it? Sorry, the 25 breaks up. And that's a 5 times 5. I'll throw that multiplication symbol in there. And so these are all in order. Yep, sounds good. There we go. 3 times 5 times 5 is equal to 75. Now, let's see. Can we use another method here? What do we know about the number 75 that we've seen before? Oh, because it ends in a 5, it's part of the 5 times table. And I'll deal with this a little bit more on the next video about dividing and so on. But right now, just kind of trust me on this and go to your multiplication table. And I want you to go to the 5 column and all the way down until you get to 75. And you know what? We have 5 times 15. 5 times 15. Good chance you may not be aware that 5 times 15 is 75, but now you know. And let's see. 5 is a prime number. There's nothing more we can do with that. So I'll just bring it down. Okay, what do we have for 15? 15. 15 is equal to 5 times 3. 5 times 3. Now you could have said 3 times 5. It doesn't matter. But I made an agreement, and I made that sort of a one-way agreement because you can't talk to me over the airwaves here. But the agreement that we said was that we were going to take the smallest number and put it first. So like over here, we have 3 times 5 times 5. They're all prime numbers. They won't break down anymore. We have the same 3 numbers over here, but they're not in the same order. So let's just order these, and then we can compare. So, okay, we'll put the 3 times 5 times 5. I have 1 3 and 2 5s. And guess what? The answers are identical. Okay? Now, this may be a video you could maybe skip, depending if you're in my class or something and I've given you this lesson, well then you may be able to skip this one, but this is going to be definitely used when we start reducing fractions, as I said, in the not too distant future. So, I'm going to leave it at that. And in the next video, oops, there I'm out of the screen. In the next video, I'm going to show you about basic division and take it from there. Okay, have a great day.